Alright guys, this is going to be a quick 5-minute video going over this one homework problem from assignment number 13. I got a lot of questions, a lot of comments and messages about this one. So let's take a look, let's see what's causing so many people so much trouble, and yeah, let's see the common mistake people are making when solving this equation. So hopefully you've already tried this, of course, and so if this were just a compounding interest, I write out the equation that models Gary's and Sasha's situation. So Gary is investing $3,000 at a rate of 1.2%, 0.012 as a decimal, but it's compounded daily, so we're going to divide by 365, and we're going to raise that to the 365th power, and there we go. Alright, and Sasha, how much did she invest? She invested $2,000 at an interest rate of 3% being compounded monthly. So there's her equation. So if you want to know when they are going to have the same amount of money in their investment accounts, well, we want to set those two equations equal to each other. So I'm just going to change the t's into x's just so it's a little easier to see and write, because those t's end up looking like plus signs. So we are trying to solve this equation. And pretty much all the homeworks I've checked so far, everyone was able to set this part up correctly, but then it's, how the heck do we solve this? Alright, so most people try to take the log of both sides at this point. Before I do that, I'm going to divide both sides by 3,000 or 2,000 just to clean up the coefficients. So let's see, I'm going to divide both sides by 2,000. So I'm going to get 3 over 2, 1 plus 0.012 over 365 to the 365x equals 1 plus 0.03 divided by 12 to the 12x. Alright, I'm actually going to copy and paste this because I'll show you a second method of solving once we get to this point in a bit. Alright, so if you try to take the log of both sides, which you can do that, it's going to look like this. Log of all of this equals log of all of that, right? That's our argument. So the problem a lot of people are making is when they take the log of this expression on the left, they're moving the 365 to the front of the log. So that is a log rule, except this 365 is not the exponent of the entire argument, right? Because this 3 over 2 is not being raised to the 365x power. So because of that, we can't just move that to the front, because, again, this is not being raised to the 365x power, right? Take a look at over there, right? And where are the parentheses? It's around our growth factor over there, right? So what we need to do is we need to treat this as like a log of a times b sort of scenario, where 3 over 2, that is a, right? And all of that, that is b, right? And we know the log of this argument a times b, that's the log of a plus the log of b. So what I am going to do here is I'm going to make all of this, when I take the log of that argument, I use that product rule, and I make it the log of 3/2 plus the log of all of that. Right? And now for just this log, I can use that power rule and bring it to the front. So just working on the left side, this becomes log of 3/2 plus 365x log of that. in a time symbol here, 365x times the log of that is equal to, well, on the right side, I can use the power rule here, right? Because our entire base is just that. So it's not a product or of something in the base. So we can just move that 12x to the front equals 12x log of 1 plus 0.03 over 12. All right. So I made this problem unnecessarily difficult, as you can tell. We have x's on both sides of the equation, so we want to bring those x terms onto the same side. So I'm going to make this log of 3 halves, and I'm going to make that equal to 12x times log of 1 plus 0.03 over 12 minus, I'm going to subtract that entire thing from both sides, minus 365x log of 1 plus 0.012 over 365. And I can use GCF factoring to factor out the x, right? Because we have two terms, one term, two terms, and they both have an x in common. So factoring out that x, I get x times 12 log of that minus 365 log of that equals log of 3 halves, and then you divide both sides by that entire factor, right? I know it's getting kind of crazy, and we get log of 3 halves all divided by 12 log of, what was that? That was 1 plus 0.03 over 12 minus 365 log of 1 plus 0.012 over 365. And you would take that, type this massive expression to your calculator, and that is going to equal x, or t if I left it as a t. And when you type that in, you get 22 point something, and it rounds to 23. Alright, so that is 23 years is when those two accounts would have the same amount of money. So you can confirm this graphically. It's way easier graphically. Just graph that equation, find a point of intersection. Right? So this is the number of years. If you plug in the 23, you would get the amount of money they actually both have in their accounts. All right. So that was one way of solving that equation. And it's the route most people try to do, taking the log of both sides. But here is something else we could do, which is actually much easier than the other version. So instead of taking the log of both sides at this point, another thing we could do is we could divide both sides by all of that. So I'm going to divide both sides by this instead. Alright, so this is method number 2. And this is going to be the easier method. Alright, so I will divide both sides by this. And so what I get is 3 over 2 equals all of this. Remember, we're trying to solve for x, but look, x is in two places. But using our power to a power rule, right, if I have a over b, let's say a to the x over b to the x, isn't that a over b to the x power? Written like so. So I have the same scenario here, where this entire thing is a, this entire thing is b, I could say. So I could rewrite the right side of this equation as all of this raised to the x power, right? Remember when you raise a fraction to some exponent, right? We're just raising the numerator and the denominator to that exponent. So that can be converted to that. And now we just have pretty much y equals a to the x, right? And so this is in exponential form. We can convert this to logarithmic form, where our base is just this crazy fraction, and that's our base. So in log form, this will be log base all of this so log base this of 3/2 is equal to x, our exponent. And you could just type all of this into your calculator, right? Your calculator lets you type in whatever base you want. So type that in as a base, and you will get your solution for x. And sorry about that. And typing that in, you get the same answer. X is about 23 years. It's around 22 point something. Round it, you get 23 years. So this way, a lot quicker, but a lot less intuitive, I think, because you gotta see that manipulation, right? Most people tried taking the log of both sides, but the key thing here when you try to take the log of both sides is that 3/2 is not being raised to that power, so you can't just bring the 365x to the front there. Alright, so definitely not something I'd put on a test, but maybe now that I've showed you 2 ways to do it, maybe I could put something on a test like this now, and you can use method number 2 if you want to solve it, makes sense. But we'll see. So that's going to be it for this video. Post the answer key to the rest of it, and see you guys later.